This video is a day one of our Agentic AI Mastery Bootcamp. So let me explain you straight what you can expect in this video. So we'll first begin with what are the 8 steps of Agentic AI Mastery Roadmap, including what are the design patterns you should be mastering once you complete this bootcamp. We'll also talk about how to start with the foundations and start straight with building agents, and then LangGraph, projects you should be working, and then multi-agent development framework. So everything that you should be learning to go from a beginner to an expert, including production deployment. Also cover one of the caption projects that will help you in understanding how these things are implemented in real world. And each of these things we are going to build over the next series of couple of videos. Then each will build on its own projects, and then we'll increase on the complexity as we build on finally. So we'll first begin with the basic concept, like basic terminologies and abbreviations and glossaries on that should help you to understand the concepts. And today we are going to cover some of these things in today's video, and in future videos you will see more and more details of that. Once we understand this is the overall picture we'll be looking at, we'll be going with AI evaluation, how AI has evolved over a period of time. Then we'll go into generative AI fundamentals. Then we'll look at some of the use cases that will be useful in terms of both generative AI and agentic AI. We are going to focus on banking use cases for today. Then we'll look at some of the language models, RNN transformers, and so on. Then we are also going to look at the transformer deep dive, and then tokenizations, very important for you to understand. Then you'll also understand the LLMs, trainings and inference. How do you control the inference? So these are some of the things which will be going deeper into rule-based to machine learning to deep learning to generative AI. Then we also look at the supervised learning, unsupervised learning, and reinforcement learning, and what is meaning of each of these to understand the generative AI and agentic AI, what the generative agentic actually means, the generative AI versus the discriminative AI and their differences. Then what are some of the use cases of generative AI in today's world, including the use cases within the banking sector. Then we'll look at some of the real world impact what generative AI is making, and we'll take some use cases in the real world from one of the banks of implementing who's implementing, and then we'll test your knowledge to see whatever you've learned so far, how much you've understood by using some of these quizzes. Then we'll also look at from rules to language models, what are those, and this is where the requirement from NNN, limitations with LLM to LSTM, and then why transformers became famous that became. And then within transformers, then we are going to look at embeddings, very, very important, encoding, decodings as well, and some of the advanced, the self-attestation, the paper that basically made GPT what we see generative AI in current world as well. We'll also look at the difference between encoders, decoders, and encoders versus decoders as well, and then transformer architecture on which you see a lot of these implementations of large language models and some of the quizzes again from this point. We'll also look at very, very important tokenization, what is tokens, tokenization, and how and where these tokenizations are stored, how they're being LLM read them and input them. So this is again things will be understanding. You'll also be, there are different methods of tokenization. Each company uses different tokenization methods, so you'll be learning and understanding that as well. And then we're training LLMs. What are the different phases of LLM, right from pre-training to fine-tuning to alignment, the different phases of LLM training as well. And then we'll go a little bit of each of these components that you see here. Then we'll also look at some of the key large language model families which are available in the market, and what are open and closed, which is open source or proprietary LLMs that you see. Then also very important in terms of how LLMs generate text, or how that inferencing happens, right from prompting to tokenization to samples, repeat, and until you finally get an output of this. And then finally we'll also look at how this basically inference is controlled by using things like temperatures, top P, and generation controls as well. Now finally we'll wrap up. This is something which you don't want to miss in the end. That is something. Other thing which we'll also be covering is that how you can access LLM models, both proprietary models and as well as open source models. How companies in enterprise world where security is a big concern, what are the options available for accessing these and the LLMs as well. And the final thing is about the OpenRouter, there's something that you need to know and understand, very important that we cover towards, and I think it'll be going to be very, very interesting for you. So this is what everything we're going to cover today. But then in part 2 and 3 and 4 series, we'll go a little bit deeper on these subjects or these generative AI mastery as well. And hey, if you're meeting first time, my name is Atul. I have close to 2.5 decades of IT experience, and these are some of the clients I've worked, and I help and I've run a free masterclass where I take you from whatever you're earning to earning in excess of $300,000 salaries in AI, Agentic AI, Generative AI, cloud, and using this three-step framework. It's absolutely free, roughly around 2 hours. We run once in every couple of weeks. So link to that free class should be up below this video. A lot of individuals like you have got results using this exactly the method which I'm going to cover in that free class, like Utkarsh or Steve or Devashish or SJ, Shovik. We have hundreds of individuals like you who have got results from this free class. So with that, if you're interested, as I said, click link below. And with that, let's go and look at the day one of Agentic AI Mastery.
These are the 8 modules I'll present to you in which you can, take up this entire learning path. We'll first discuss about the foundations, we'll build the first agent, and then we'll create elaborate workflows using LangGraph. From that, we'll start building multi-agent systems. In the third module, we'll talk about different frameworks which are used to create these multiple agents. And then comes a very recently developed topic. This is still, people are still figuring out about context engineering and how to do end-to-end evaluation of the agentic system. That is all about it. And then guardrails and entropy, these are very important concepts again for the enterprises. PII reduction, so any enterprise grade application has to implement these guardrails so that customer sensitive data doesn't directly go to these models and agents. Okay, so you have to put a security layer. So that is all about the module 6. In module 7, we'll start deploying these agents into local and cloud. And then finally, I'll also present to you with 3 end-to-end capstone project ideas that you can pick up based on your choice and domain preference, you can say. So largely these are the things that you will be mastering in these 7 modules. These are the kind of workflows and these are the agentic systems. So workflow is pretty much linear in nature or sequential. You do this, then you do this, then you do this, and then you do that. So these are the called as workflows. Okay, you can chain prompts, multiple LLMs using these prompts. You can route the API calls to multiple LLMs based on some conditions. So routing is conditional routing. Parallelization, you can make parallel API calls to multiple LLMs for different actions. Okay. Orchestrator, so here one of the LLM decides which other LLM to be used for a downstream task. Evaluator optimizer is like one LLM will generate some output, the other LLM will evaluate the quality of the output from the previous LLM. So again, these are all sequential. HITL is human in the loop. So LLM generates and I as a human will evaluate the quality of that response. But now when we talk about agentic systems, you have multiple agents which act autonomously. Okay, React agent is reasoning and action. So LLM will take the user query, do some reasoning, and then do some action based on some tools. And then the output of that tool will be given back to the LLM for observing and taking further action. So that loop is obtained in your React and so on in the next 4. So see, the whole thesis is we don't want to take theory and then uh, take isolated labs which feel disconnected. Okay, this time I have redesigned the entire roadmap such that we directly start with the projects right from the day one. Okay, we have a clear requirement with us that this is the business scenario, this is the problem that we are facing, and this is how we are going to solve it. Okay, so the entire learning within this roadmap is going to be project based learning. Okay, so the first module itself, we have the first project in which we'll be building a financial analyst RAG agent. And this is like a React agent, as I mentioned in the previous slide. This is like a React agent. There will be some query coming from the user, and this LLM will reason which one of the tools to use to answer the user query. Once these tools are executed, the output will be given back to the agent for observing the tool's output. And once the agent has all the required information, it will give an answer. That's the whole pattern. So we'll also talk about concepts like context engineering, token budgeting, just-in-time retrieval, RAG pipeline, and we'll be largely using LangChain for the orchestration, FAIS, that is a Facebook AI similarity search as the vector database. And most of the models being used will be coming from OpenAI models. Okay. The next module, we are going to go into core agentic architectures coming from LangGraph. LangGraph is a specialized Python package for building advanced agents. So the previous agent was done using LangChain. This one will be done using LangGraph. Okay. So these are advanced patterns like I was talking about routing to different agents based on some conditions. Okay. So for example, user is asking some questions now, based on the context and the sentiment, the router will decide, okay, the billing agent will answer, or the technical agent will answer, or a general agent will answer. So handling of the user query will be decided based on the category of the question. That is the routing. Prompt chaining, again, agent one gives a response, and then that response is taken by the second agent for the improvement and the next step. That's your prompt chaining. Parallelization, multiple agents will work in parallel and together submit their output. So think about a scenario. Let's say you want to research on a topic, could be like something like quantum computing. Now the worker one is doing search on Wikipedia. Parallelly, worker two is searching uh, you can say the entire web, and worker 3 is searching some specific platforms like articles on Medium. Okay, and then once all the three results are available, then they are aggregated and the final agent will read out all these summaries from these three agents and give you a final more comprehensive answer. That's like a parallel agent. Okay, human in loop, where the output draft coming from a model will be stopped, paused before going to the next step. You, as a human evaluator, expert in that domain, will give a go ahead or modify before it actually goes to the next step. So these are the things that we are going to discuss in a module 2, different patterns as I've already mentioned. We'll also talk about how to create context and memory for these agents. So the second project, which is a customer support multi-agent system, um, coming from an e-commerce kind of a domain, and this is the overall business problem that I have mentioned here, where we'll be routing the customer queries to different agents based on the nature of the query. It could be order tracking, or it could be returns or recommendations. So based on the user query, these agents will be able to take the call, how to answer, where to answer, and their answers will be grounded from company policies, product documentations, product descriptions, return policies. So which will be specific for each of these products, right? The agent cannot build up answer that this particular product had a 7-day return policy or a 15-day. It has to actually search for that product description in the knowledge base and then come up with that answer, well researched answers. And you can also put the human in the loop as well for some of the trickier queries and something like that. So this entire end-to-end project, more like a production grade, I have mentioned here. So this is I'm proposing to be built in the third module. And why I'm calling it as a spine project is this project we will make it even better in the next modules. Okay. So project 3, where the module 3 and project 3. So the third project will be again a compliance report generator. This is a super useful uh, agent, I would say, or a project for people who are coming from compliance heavy domains like, let's say, banking, financial services, and insurance sector, including healthcare domain, because there are mandatory compliance filings which happen every month, every quarter. Okay, how do you, and there are, for each of these compliance filings there are templates as set out by the regulators. So we want to create agents which can work all on the different sections of the report generation. They will do their independent research and they will fill out. So this is like what we call as the fan in fan out pattern, where multiple agents will work in parallel. They will do all that research, section writing, and they will give all their generated responses to an evaluator agent who will check if there is something missing, if something was overstated, if something is not correct as per the compliance regulations. Everything will be checked thoroughly, and then it will pass through a human to give a go ahead so that it can generate the final report. Okay, you can also set how many times, because if the evaluator finds that something is not right, it will go back to the worker agent. Okay, boss, you have missed this. Why don't you complete that and send it to me back again? So this cycle is also going to be implemented. So this is going to be very, very interesting project. Uh, this is your compliance report generator project number three. The next module, again, we are taking another very advanced multi-framework agent development, again, which takes multiple platforms. So the main framework that we'll be using is Crew AI rather than LangGraph. The previous one we did talk about the LangGraph. So you can actually build multiple agents using LangGraph or OpenAI SDK or Crew AI. AutoGen is another very uh, important framework coming from Microsoft. Google has also recently launched their agent development kit ADK. So we'll talk about these multiple agents frameworks. We'll talk about pros and cons and so on. But this project will be finally built using the Crew AI. Okay. So this Crew AI powered content factory will have a researcher, content writer, editor, designer, all of them working, in a sequence to create a blog post. So that whatever you are learning as an outcome, you should share on social media. So can I create an agent on my own who does all that research, who does all the who has all the context, okay, that I provide, and then will give me a entire LinkedIn post, okay, along with the image and the markers and everything. The entire content formatting will be done by this agent. So that kind of an agent will be building, so that your agent starts writing your LinkedIn post or Twitter feeds. So that is the whole idea about in this project. So when you are talking about these agents, the conversations with the agents can go, multi-turn, and maybe easily the context window of these models can get exceeded. Okay. And more importantly, if the input tokens and the output tokens are huge, okay, it can be a bit difficult for the model to keep everything in memory. So how do you manage that amount of context so that you feed the right amount of context to these agents and to these models? That is all about the context engineering. So we'll learn about prompts, budgeting, retrieval, compaction, summarizing the prompt, summarizing the conversation summary. You might have already faced, if you have seen in ChatGPT or Claude, when your conversations become very, very long, sometimes it takes a moment to compact the entire conversation. It says that the conversation has become very lengthy. I am compacting the entire conversation. The same kind of thing we will implement explicitly. That's what we call as context engineering. Okay. So we'll use some reusable skills and some instruction packs which can do this context engineering. That is part one. In the second part, we'll also talk about a end-to-end evaluation of our system. So whatever we have been building, there has to be a mechanism to evaluate the efficiency and efficacy of that system. So first, we'll start with evaluating different agents as a fitment for our agentic solution. So which agent should I use? Should I go with OpenAI agent or a Claude agent? Should I go with a multi agent, open source agent, or agent coming from a specific platform? So all of these LLM evaluations we will do, and then we'll learn about RAG evaluations. So RAG primarily contains two parts. One is the retrieval system, one is the response generation system. So there are specific metrics for retrieval system and specific metrics for the generation. Okay, we'll talk about different metrics like precision, relevancy, context, and then you can say mean reciprocal rank. Okay, so all of these are the metrics for RAG. And then we have been building these agents. We want to evaluate these agents also. So there are metrics for task completion. You gave a overall task to the agent, and what part of that task the agent was able to solve in a given amount of time. Okay, or tool correctness. Did it use the right tool which was meant for solving that task 100% of the time, or it only did 96% of the time? And then trajectory, how many times it deviated from the expected trajectory or path, because it is an autonomous, so it will decide its own trajectory. So as a human, we know the right trajectory for a specific task, but how much of that trajectory was actually followed by an agent. So there are many metrics in which you can actually evaluate the end-to-end agentic system. This is going to be very, very useful and very interesting topic there. So pretty much. So basically, you cannot directly give the user requirement to the agentic system, because the user can, do some sort of a prompt injection or give malicious prompts. That is very popular now these days. Okay, so input sanitization is very, very important before the request goes to the agent for execution of the task. PII reduction means personally identifiable information. You can't give customer sensitive data to these models. Okay, so you should be able to mask the customer names or user names, IDs, which are, let's say, SSN IDs, Aadhaar card IDs, and so on. Okay, with some masks, generic masks, so that these agents are not learning on customer specific information. And then whatever is the output coming from these models, that has to also be made sure that it is safe for work. It doesn't have abusive nature, or it is pretty neat, clean, and professional. So toxicity detector, hallucination check. So all of these things can be implemented. And finally, a human in loop to make things, everything, okay. So in the project 5, largely which is going to be built on MCP. So we'll learn how to use the MCP and A2A protocol. An end-to-end project will also include the Langsmith and Langfuse observability. So I briefly talked about observability, which is basically a 30,000 feet of the entire system. Okay, what is really happening in each and every step. And traceability means, let's say if there is a bug or an error, you want to drill down each and every step. API call, you want to see the latency, you want to see the token usage, you want to see the overall cost for each and every API call, what actually went into the model, what came out of the model. That is like traceability. You are going through the each and every log input. Okay. That is your traceability. So that is also what we are going to implement in this project number 5. Okay. And 6. So that is the module 6, and now is the module 7, where again the sixth project is on Google ADK, that agent development kit, and we'll be talking about a banking agent. Okay, that will have sequential, parallel, and loop kind of a workflow. We will also deploy this agent on Docker. Using Docker, Fast API will be the framework to serve these agents. There will be API endpoints created using Fast API. The end application will be Dockerized, and then we can deploy it on EC2. Okay. We'll be also setting up reverse proxy for Nginx, which will take the scalability of your agent. Basically, multiple users can directly jump into your agent and access them parallelly. So that is all handled by Nginx reverse proxy. So you will really build a system which can be accessed by anyone across the planet. So that's the takeaway from this seventh module. Okay, you
And
will get a publicly servable IP. So say that is the main agenda. So most of the previous agents, they have been on Jupyter notebooks. We will take those agents out of the Jupyter notebooks and take it to the production deployment. Finally, I'll be suggesting 3 capstones. You can pick one of those depending on your interests, or maybe one of those uh, capstones we can also take it together. So these are the 3 capstones I would suggest, which has most of these you know agentic design patterns, different business use cases, different challenges, slightly different architectures. But the idea here is you should be able to demonstrate your learning via end-to-end capstone. This should be largely done by you, 80%. I can give you a high level idea, high level steps, high level guidance on the frameworks and the architecture, but this literally has to be done by you. Of course, we'll have some sessions to discuss your solutions or your thought processes or some validations if you need one, but this will be largely done by you. I don't want to provide you a ready-made code that you execute on your machine. That is not the expectation of this particular module. So you have to make yourself production ready. So basically, here the idea is not to just uh, focus only on the theory part. The entire learning has to come from doing, and Doing doesn't mean that it's only that I do. You have to do parallelly. You will have to put in additional effort. So for each of these projects, I'll also give you some stretch goals and challenges. Okay, that will help you to take your learning beyond what is already given to you, or served to you, code and all. So that will give you a real confidence that you can take it ahead. So you'll be mastering all these frameworks, patterns, evaluations that we have talked about, all sort of guardrail security, you know production deployment. And ideally, by the end of this roadmap, you should have 8 end-to-end projects in 8 GitHub repositories. So that is your net deliverable. Okay, you're not saying that, hey, I have done some random AI agent certification. No one cares about that statement. You should be able to demonstrate what you have learned. So don't say that I learned this, I learned that. No one is there to hear out that. Okay, whereas if you are sharing that, hey, I built this project and this is what it does, let me know what you think. I'll be happy to take your comments. So that is the kind of sharing engagement with the community that will help. So share of all of your projects over LinkedIn, GitHub, and get feedback from the community and improvise and improve. Okay, this is a quick abbreviation and glossary which might appear in the later part of the presentation. Okay, everyone all knows about AI, ML, DL, NLP is natural language processing. LLM is your large language model, which is transformer based text model. I'll be referring to that extensively. Gen AI is all about generative AI. This is just abbreviations. Okay, the detailed discussions will be there within the presentation. Okay, GAN, whenever you see a short form GAN, I'm referring to a generative adversarial network, which is typically a model used for generating images. GPT 1, 2, 3, 4, 5, your OpenAI model is a generative pre-trained transformer. That is the name of the model from the OpenAI LLM family. Okay. BERT is bidirectional encoder representation for transformers. So BERT models are made by Google for embeddings. What are embeddings and all that we will discuss in another presentation. Recurrent neural networks, type of neural networks which is used for sequential data processing, like a time series data or text data. Text data is a sequence of words. So that's a sequential data. Okay. LSTM is long short-term memory models. This is a specialized type of recurrent neural network with a lot of gates, memory gates, forget gate, retention gate, input gate, output gate, and so on. Okay. And then there are different types of tokenizer models. We'll talk about tokenizations and so on also. Byte pair encoding is one of these tokenization strategies, which is used by GPT models. Okay. The other tokenization strategy is so all about tokenization, what it is, what are the different algorithms, why should we, bother about tokenization at all. So those things I'll share it in a different presentation I have, okay, later. And then the topics like fine tuning, supervised fine tuning, reinforcement learning, and then this is the type of alignment tuning. Okay, direct preference optimization. RAG we will discuss about in another presentation in detail. API is application programming interface. Whenever we want to make API call with these models, okay, API call with the model means how do you access the model which is hosted on a third-party server? So how do you call that model? That information sharing or that communication mechanism is called as an API. Okay. Usually REST API. There are many other things, but REST API is what we'll be using very extensively. Okay. Let's go ahead. So today's quick roadmap, we'll be discussing all of these topics. Okay. Right from AI evolution, Gen AI fundamentals, banking use cases you will find very extensively because that training was extensively done for a banking client. Okay, JPMorgan Chase. I have been doing a lot of trainings for them. So this some of these training materials are being repurposed from there. Okay, some only small part. So you might predominantly see some of the banking use cases in many of the examples in the notebooks as well as in the slides as well. But that's okay. I've tried to make a balance between other domains as well. You will see. And then language models, what are they? Transformer architecture will not it's written deep dive, but we'll just discuss at a very superficial level. What is tokenization, LLM training? How does that happen? What are the stages, steps, and then finally, how can we control the outputs of these models? So, okay. So AI contains, I think the previous slide I missed. Yeah, this is the evolution. So you can very well see that AI is not new. It has started from somewhere in 1950s. People started making machine learning models, especially, and they are even relevant today. So for example, even most of the banking use cases reuse logistic regression for fraud detection. So reason for using logistic regression even today, although this is a model which was created, I would say 40 years ago, is compliance, regulatory requirements. They want a full visibility of the model's outputs. They want a full explainability. So wherever models visibility, explainability is very important, you still fall back to traditional machine learning and deep learning algorithms. So deep learning became popular 2010 onwards or 2012 onwards, where the GPU availability and a lot of data availability in cloud started coming into picture. Okay. So and the transformer architecture, the paper came in attention is all you need. So that is where it triggered the generative AI. It's not that the generative AI was not there before that. Folks were able to create some images in 2014 using the GAN models and variational autoencoders, but those are were very basic image generations, or I would say variations of the input image. Okay, true generative capability started somewhere around the 2017 with this transformer architecture. Okay. So in machine learning, we have three different paradigms: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, you will have labels, and you are mostly going to talk about classification and regression. Unsupervised, the main applications are clustering, customer segmentation, grouping similar objects or grouping similar data points, similar documents, similar customers in one bucket. Okay, similar customer profiles, similar usage pattern, recommendation systems, dimensionality reduction. These are all unsupervised. And reinforcement is where you want to teach a machine to learn by trial and error. Like you want to teach a robot how to walk or climb stairs. That is reinforcement learning. Okay. So generative AI is basically uh, a model we want to create or use a model to create an entirely new content. Now, new content could be text, image, code, audio, video, any of these modalities or a mixture of these modalities. Okay. Um, so some examples are there again. Uh, so what these models can be used for, you can see. So for example, you want to use any of these models for generating a loan denial letter. Now, let's say I applied for a loan and for some reasons, my loan application is not successful. Now, the bank wants to draft a customized loan denial letter for me. Okay, so that is the place where they will use a generative AI model to have a customized, you know, email drafted for my use case, okay, for my profile or for, with whatever exact reasons. Okay, so these models would have already learned from billions of tokens during training how a banking correspondence looks like, regulatory filings look like, compliance documents are. It would have already learned the structure of emails, tone, and regulatory language used in the official banking communications. This is all coming from its training data. And then it also understands the application type, denial reasons, DTI is debt to income ratio, for example. Okay, and then required disclosures. EQI is equal act. A is for act. Uh, I'm also forgetting the full form, but it is Equal Opportunities Act, something like that. Okay, so these are the regulations in US, and FCRA is again the same. So model contextualizes these facts against the learned patterns, and finally it is able to generate email which is highly relevant, okay, for the use case, not just a generic one. Okay, so model generates each word based on the all the preceding context. It produces professionally worded letters citing specific denial reasons, required adverse action notices, or credit bureau contact information. Applicants' right to request specific reasons within 60 days as per the EQA. So basically, what it is trying to say is, if my loan application has been denied, I have equal opportunity and right to ask the bank for a written explanation. Okay, whatever be my caste, creed, region, religion be. So that's what the regulatory norms specify. And then there has to be a human reviewer. So this is the typical workflow, you can say, very critical in banking. So GenAI can assist but cannot replace the human judgment. So there has to be a compliance officer who will verify all these disclosures are properly complete, the tone is appropriate and not, let's say, demeaning or abusive, okay, based on some particular region, religion, or anything. So no protected class information is there, which is influencing the decision. So this human in loop is a regulatory expectation. So you will use these GenAI models to assist your workflow. These models still cannot replace the humans. Okay. It's just that you don't have to sit down and draft that email for half an hour. Some model will do it within, let's say, 30 seconds or 1 minute. You will have to put your time and effort in reviewing it, making sure that it follows all the compliance properly and the process. So finally, a quick discussion on Gen AI and discriminative AI. So generative AI is where you are creating new content using all of these models like GPT, Claude, DALL-E, Sora models. And discriminative AI is where you are using the machine learning model, deep learning models for prediction of the classes. You can say, so what do you mean by this? A email can be classified as spam, not spam, or a document can be classified as invoice or a receipt, or a medical document versus a legal document, or image classification can happen. So, for example, a customer has submitted a KYC document. You want to classify it as a driver's license versus a SSN or Aadhaar card. Okay. So that kind of KYC classification can also be done. Okay. Image classification. This is Prashant's image versus Tom Cruise image and so on. Or Prashant's legit signature versus someone else's signature. So that is also very important. Okay. So all these models can do all these things very nicely, neatly. So you can flag the fraudulent transactions. You can score the credit risk. So for example, if I applied for a loan, credit score, risk score can be, credit score is different and risk score is different. So credit score like TransUnion, CIBIL, CRIF, Highmark. So these are the credit scoring companies. And risk score is basically scoring my application on a scale of 0 to 5 or 0 to 10. Okay, how likely am I going to default? Okay, so that is the risk score. Okay. You can also use these models to classify customer sentiment. Okay, so for example, I've given some feedback about a product or a movie. Okay, so my, or even my customer complaint I have submitted, or this could be a feedback or appreciative feedback also, right? So what is the customer sentiment? So let's say I want to place a checkbook request. That's neutral. But if I'm really frustrated about a particular product or a service, it can be, so these models can be used to identify those, negative sentiments and directly can take for human escalations. Okay. So predicting the loan default rates, customer churn prediction is another very important area for banking, telecom industries, and so on, right? So the generative AI task universe, what all things can be done by these Gen AI models? So text generation, you can generate reports, email summaries, regulatory responses, code generation. A lot of these examples we will see in our agentic course as well. Image generation. Uh, I think I told you that in my presentation, all these images were generated by these models. All these images have been generated by these models, literally, right? Even this image, even this image, this image, this image. Okay, this one at the bottom, even this one. So that is the kind of image generations I can have. So audio generation capabilities, this we have seen very extensively in the GenAI Mastery course. We have used some of the services like Poly. And video generation like Sora, you can use multimodal models are there which can take a document, convert it into images or convert that into infographics or convert that into a audio, speech, text to speech. So all of these can be done by a single model. That is what we call as multimodal. Okay, so banks process scanned loan applications. For example, you are a customer submitting your KYC document as a scanned document. Let's say maybe your electricity bill or a address, uh, home rent agreement, anything. Okay, so extraction from that image document using a OCR and then doing some analysis on top of it, extracting the key entities like names, addresses, timelines, those things, and analyzing also the financial charts, handling mixed format, regulatory submissions. So a lot of these can be done by these GenAI models. Okay. Okay. Now these are all different applications which you can read it once you have the presentation. Okay. And let's go ahead. Some real world applications are also there, as I said. So, for example, this is something which, let me show you, JP Morgan's JPMC coin. Uh, that is contract intelligence. Okay. Okay. Contract intelligence. So, a simple example of how JP Morgan is using AI to save 360 legal hours a year. Okay. This is Agentic system that they have built, which they call it as a contract intelligence. Okay. What it does is scans, understands all the legal documents, extracts key clauses, cancellations, rights, and obligations, converts unstructured data into structured form, learns from prior documents and annotations. And it is really saving a lot of manual work, you can see. Okay. This is okay. I'll show you that from a, you can see a lot of. Okay. And this is what I was talking about. And then Citigroup is also using regulatory document analysis using all of these agents. Okay. Morgan Stanley is using these agents for AI research assistant for their wealth advisors. So they have 16,000 advisors accessing 100,000 research reports. So they have agents for their enterprise which scan and research through all these 100,000 reports, research reports, and before every meeting with a potential client or a customer, these advisors uh, make a very heavy usage of these agents to prepare for those meetings, for those reports, and so on. Okay. So these advisors can ask natural language questions about the market conditions, portfolio strategies, and product details. And that and this is all synthesized answers in seconds instead of hours. So they don't have to do manual research now. Their agents are already doing this. So some enterprise applications which are already in production. So that was the point here. Okay. So it's not that whatever we are learning is just for the sake of it. There are already existing enterprise grade applications, and these few companies are already benefiting from all of these investments that they have made and done. Okay. Yeah, you can see. Anyway, so let's come back. Time for a quick quiz. Okay. So which AI paradigm focuses on creating new content? Come on. We know this, right? Generative AI. Fantastic. Well done. Bank's fraud detection system flags transactions as fraud or legitimate. Fine. So this is an example of discriminative AI. Correct. We want the model to discriminate. We want the model to discriminate whether a transaction is fraud or legitimate. That is the reason we are using the word discriminative, because we want the model to discriminate. So model has learned how to discriminate from the previous historical data that was given to the model during its training phase. Clear? Which of this is not a common GenAI task in banking? Question number 3. SAR is suspicious activity report. SAR is suspicious activity report. So drafting SAR narratives. When do you want to draft the SAR narrative? Let's say a transaction has come and the risk team, okay, has flagged that transaction, or AML team has flagged that transaction. AML is anti-money laundering. Okay. So then they will do a forensic analysis of that transaction and generate a suspicious activity report based on the compliance. So definitely this is a GenAI task. Real-time stock price prediction. So for this, you can use a normal time series analysis, or you can use a machine learning deep learning model. So this is not a GenAI task. Correct. Generating client update letters. I gave an example at the start of the discussion also. My loan application was denied, and the bank wants to send me a customized denial letter. Okay. So that is where you will again use this GenAI model. Okay. On the right side, according to EY Parthenian's 2025 survey, what percent? Now that number was hidden in one of the slides. I'll give you the answer. Okay, I skipped that, but the answer is actually 47%. So 47% of the banks have fully implemented GenAI actually, and this is the reality. Don't think that people are still thinking and experimenting. This is the reality already. Okay. Why did the deep learning revolution accelerate around 2022? Why do you think so? Gave the hint. I gave the hint. Let me see how many of you noticed. Transformer architecture 2017, not 2012. ChatGPT was released in November 2022. November 2022. ChatGPT. This was 2017. So correct answer is GPU availability started. Okay. And this AlexNet was made in 2012, right? Super. So the next thing is how did we, or how do we proceed from rules to language models? So rules means you are writing down a set of rules to teach a machine how to comprehend language, but these are very brittle rules, not very helpful. So basically, based on previous words, you want a model to predict the probability of the next word. So this is how you would read. So you want the model to predict the probability of the next word based on the previous n minus one word. So, and the nth word, probability of the nth word based on the context, which is the previous n minus one words. Okay. So these are what we call as the n-gram models of simple counting and probability limitation. We can't capture long range dependencies. So for example, the loan officer who reviewed the application last Tuesday approved it. So requires remembering across many words. Okay. So last Tuesday, what was it? I mean, a lot of long range dependencies need to be remembered, and that cannot be done by using these n-gram models. What are n-gram models? Please search. This is not the GenAI session on that. I'm just giving you some keywords, how things have progressed. Then we started talking about recurrent neural networks, okay, in which we were training, deep neural networks. It's a specialized type of a deep neural network, you can say, which processes one token at a time. So token is a word or a part of a word. If you are completely new to the word tokenization, open this page called as OpenAI Tokenizer, and you can see how these models comprehend language. Okay, how these models comprehend language. Okay, so for example, okay, so my name is Prashant. So model comprehends this using these six tokens. This is the first token, second token, third token, and my name is actually split across three tokens. So this is not an English word. So anything which is not a dictionary word typically gets split. That is why we referred it as a sub-word tokenization, because each word can also get split into a token. What is important to understand at this point? These models are generating sentences or entire text token wise, not word. Okay, the unit of this token is the unit of all the text generation and counting and pricing, I would say. Okay, pricing means billing. So if let's say if the model generates this sentence, my name is Prashant, this is what is generated by a model. I will be billed six tokens. At what rate? You can just open any of this page, open AI model pricing. And please refer to all of these at your own time later. Not now. I'm just sharing the links. Please keep these links bookmarked. Okay. So I'll just flip to or refer to one of these. You can see here. So if you're using the GPT 5.4 model to generate this text, if you're using or you are giving this as an input, okay? So let's say I'm asking a question, what is the capital of France? Okay. This is the question I'm asking the model. Okay. This is the question I'm asking the model. So I'm build 7 tokens. And these are the tokens you can see. Mostly you can see each token refers to a single word, but it may not always be a word. Okay, it can be a part of the word, especially if that word is not a dictionary word. Remember that. Okay, so I'll be billed at this input rate. So for 1 million token which goes as an input to any of these models, I'll be billed $2.50. And if the model is generating that output, okay, let's say the output comes out as the capital of is Paris. Okay. So this is the output which comes out from the model. Let's assume then how many tokens? Again, 7 tokens. So I'll be billed again at the same rate. So maybe let's go to Grok and I'll actually demonstrate this. GROQ. Okay. So you will, okay. So my question is, I'm just selecting one of the models on the right side, 8 billion instant model. Let's say what is the capital of France? Okay. And just press submit button. The capital of France is Paris. Okay. This is a live example now. In the previous case, I was just asking you assume. Now we are not assuming anything. This is a live example. Okay. So this is supposed to be but you can see it's misspelled. That's okay. So input tokens 43, and you might be wondering how come it is 43 because there is some system prompt also, okay, which has gone along with it. Like you are a helpful chatbot, you should answer the user question in a helpful manner. So there is some system prompt along with the user prompt. But the output that has got generated is 8 tokens. Can you see the output has got generated is 8 tokens? Okay. So you need to understand that everything which goes into the model and everything which comes out of the model, a language model, which is a text generation model, everything is counted in terms of tokens. Tokens is your basic fundamental unit. This is the first and most important lesson that you are going to take away from today onwards. Okay, because I'm not going to explain what is token, this token, that token later on. So please make yourself comfortable. Okay, if you are still not very clear what is a token, maybe you can take help of ChatGPT and ask what is token, what is tokenization. So tokenization is basically a process of splitting an entire block of text. Let's say this is a entire block of text. I want to split this into smaller parts. Okay. That is called as tokenization. Different algorithms are used to split this block of text into smaller units. Those algorithms are called as tokenizer algorithms. And one of those tokenizer algorithms are byte pair encoding, or, that is what I had shared in that Gemini chat. Okay. So byte pair encoding, sentence piece, word piece. Okay, these are the different types of tokenizer algorithms. Okay, so the same text, okay, the same text will be tokenized by different models in a different way. Remember that. Okay, so the same text. So, for example, this is the text which I'm giving as input. So this is how many tokens? 52 tokens. But if I give the same text as input to maybe some other model, that might be 55 tokens or 40 tokens or 60 tokens based on what algorithm they are using to break down this text. And you can see each token is highlighted here. Okay, each token is highlighted. So OpenAI itself is 2 tokens because OpenAI is not a dictionary word. So you can very well see open is one word and AI is another word. Apostrophe S is the third token. So this entire thing for a human is one word, but for a machine it is ultimately 3 tokens. So remember, let me summarize. Moral of the story is this. So all the prompts or inputs that you are giving to the model for content generation as instructions or anything as context, that is counted based on the tokens. Token is nothing but a smaller unit of text. So text has to be split using some logical algorithm, and every model uses its own tokenizer. Don't think that the tokenizer logic or breaking this text into smaller unit is same across all models. No, Gemini uses a different tokenizer. Okay, let me tell you, Gemini uses a sentence piece tokenizer. You can go to that Gemini chat and check. Okay, so Gemini uses a sentence piece tokenizer, whereas OpenAI uses BBPE. Okay, that your byte pair encoding. So that's how these different vendors or models from different vendors are different, fundamentally, architecturally also. Second, they have been trained on a different amount of data as well. So OpenAI has used some different type of data to train their model. Gemini has used different type of data to train their model. How do you count that amount of data, quantity? So that quantity of data is again in tokens. So their corpus size, corpus is the collection of all the documents. Corpus is collection of all the documents. So their corpus contained, let's say, 800 billion tokens or maybe 1 trillion tokens. Okay. Whereas Gemini's might contain 500 billion tokens. Okay, or 600 billion tokens. They don't reveal because these are proprietary models. They would not reveal it publicly. But for the open source models, if you go to their papers, okay, you'll find the amount of corpus that these models have been trained on. So for example, this GPT 5.4, this has been literally trained on 2 trillion tokens. So all the training measurement, all the pricing measurement, input and output generation, everything is counted in terms of tokens. So please make yourself very comfortable with this concept of token. Okay, so today's your task is to get yourself comfortable with this word called as token, tokenization, model pricing, tokenizer. Okay, so that is all it. You can see when I put my cursor here, it gives me all the metrics. Okay, the reason to come to Grok is to show you exactly, because this kind of token counting you would not get in ChatGPT, right? So every time I want to actually demonstrate the tokens, I normally prefer this Grok platform where you have a complete visibility, how many tokens got inside, how many tokens were generated, total number of tokens. And inference time is basically the time it took to generate that response. So that was generated in literally 0.01 seconds, or you can say 10 milliseconds, literally in this case. Okay. So and that is at a speed of 1210 tokens per second, you can say. And it processed your input at the rate of roughly 21,000 tokens per second. Okay, that is the rate at which. So round trip means from your API call to the model till the response generated and displayed on the screen. This entire round trip took 164 millisecond as the complete latency. And this was the model that was used. So fine. Uh, so RNN for sequential data processing, but it had a lot of problems like vanishing gradient problem, and it was not able to process data in parallel. So you had to, process all the documents in sequence, which made the training of RNN is very slow. So LSTM came into being where you can selectively remember or discard information. That was better in handling some of the drawbacks of the RNN. For example, vanishing gradient problem was solved by LSTM, but again, it couldn't scale to billions of parameters. Or if you want to train your model with literally trillions of token, that was not possible for the LSTM. And that is where the transformer, you know, became a big win. So it can process literally all the tokens in parallel using self-attention mechanism. No recurrence, no convolutions, scales beautifully on GPUs. If you use one GPU or 100 GPUs, that transformer architecture scales very nicely. Okay. And this paper, attention is all you need. You should check this out once. Uh, Attention is all you need. This is your transformer architecture original. Oh, sorry. Yeah. So the left side is your encoder part, the right side is your decoder part. Okay, so inputs are processed. And so the encoder part job is to understand the context and the meaning of each and every token. Because the first thing is inputs will be tokenized. So this left side understands, that is language modeling. What is language modeling? Understanding what that text means. And the right side is the decoder part, which will generate tokens. So how is the text generated? Again, token wise. Okay, so remember that. This is a basic fundamental of transformer architecture, encoder and decoder. You don't have to understand what happens in layer by layer. That's neither the intention of this program. But remember that the encoder is to understand the context and the meaning of the text after it has been tokenized, and decoder will generate text again one by one in tokens format. Okay. Okay. So main reason that transformer architecture became very popular is parallel processing. It could process all tokens simultaneously versus sequential processing in the case of RNN. Self-attention. So what is self-attention? If you go to self-attention. So if I just search self-attention, basically it means that how each word in a text is connected to other words. How each word in a text is connected to other words. So that is what the model learns by paying attention to the relationships between these words. So for example, I can, a lot of technical things are there. Okay, so for example, if you have the word the cat sat on the mat, okay, I'll take a very simple example. The cat sat on the mat. So cat and mat, they are related because one is subject, one is object. Then cat and sat, one is noun, other is the verb. So model pays attention to the relationships between these uh, tokens. Okay, that's the meaning of self attention. Okay, so we don't have to understand this very much in detail, but just a high level that okay, any token can attend to any other token regardless of the distance. So for example, one token can be 200 tokens away from the other token where it is attending to, or maybe 2000 tokens later, the context gets repeated, or the context gets connected. That is also fine. So this model will be able to connect the relationship between this token and another token, which might be even 200,000 tokens away. So the distance doesn't matter. So attention mechanism pays proper attention to every word, and every word means every token and its relationship with all the other words or tokens in this entire text. Okay, that way the model understands the relationships and the context and the meaning of every token with respect to all the other tokens. Okay. So designed for GPU parallelism, and that enables billions of parameter models. Like, for example, your this model which I used currently for response generation. Did you pay attention? This is your Llama 3.1 model. 3.1 is the version number. 8B is the 8 billion parameters are there in this Llama model. This Llama model is from Meta AI, Facebook. So 8 billion parameters are there in this. That is how. And now you can actually see we have a 70 billion parameter model also. Now latest generation models are Llama 4 Scout model, 17 billion parameters. And then you can also uh, access the models from Gwen. This is Alibaba AI. Gwen models are there, 32 billion parameters, or even from OpenAI, that is 120 billion parameter models. These are all open source models. So what is this platform? Grok platform. This Grok platform is hosting open source models. These are all open source models that you can access for free. It's a free service, but open source model. Remember that when you are using ChatGPT, it's not open source model. It's a proprietary model. Remember that. Okay. So Gemini model is a proprietary model. Claude is a proprietary model. Claude Sonnet, Claude Haiku, Claude Opus. So all these models are proprietary models, and these are open source models. Okay, what do you mean by that? Open source model. Literally, if you want to use these models in your local machine, you can do that by downloading these models to your local machine. Yes, that is also possible. But to download these models, you need GPU. So since most of you guys would not have GPU, what is the plan B? Plan B is, can I use these open source model completely for free when it is hosted by some third party server? And that third party server is your Grok platform. So that is doing a good community service for us. Okay. Almost all my notebooks have two modes now. This is another big change I have done in this cohort. Okay. All my notebooks subsequently will be compatible to two APIs. One is OpenAI if you have it, or Grok API. So if you don't want to invest in OpenAI, you can use all of my notebooks with Grok API. Okay. How do you do that? There is API keys. You create your keys clicking on this link. Okay, it's a free sign up. Create a key, which is very simple. You just have to follow the on screen instructions. So there will be a key, and you add that key in your Google Colab by the name Grok key. I'll just share this. This will be your Grok API key. That is the key name that you will be adding in your, and I'm again assuming that you would already have your OpenAI key. So at least one of those two keys must be present for all the subsequent hands-on. Okay, one of these two keys. So Grok API key you are going to get from the link which I have just shown you. OpenAI key. For that, you will need to create a project. Let me just show you that. So go to the settings. So first create a project. Okay, ideally you should create a project. Let's say I've created one project, maybe Agentic, whatever it is. And then on the left side, there is a API keys. Okay, project, and then there is API keys. Click on that side. On the top right, there is a new key. So from there, create a new key, copy that key and paste it in your Google Colab, right? So these are the quick steps, but those keys will not work from OpenAI unless you have a decent balance in your account. How do you check your balance? Go to the billing part and you will be able to see how much balance you have in your OpenAI account. If this is zero, your OpenAI key will not work. That will give you 429 rate limit error. Let me repeat that. You will get a 429 rate limit error if this balance is $0. Okay. If that is the case, then Grok will still work because as I mentioned several times, Grok is free. Okay. And most of my notebooks are going to be compatible with Grok as well. You just need to change the name of the model appropriately. Okay. So I think we are good here. There was one very good question. What do or what is the enterprise practices or what are the enterprise practices while using these models? Okay. So let me just do a discussion on that. So you can say these LLMs or whatever models we are referring to. Okay. The question is ways of accessing, not training. Okay. These models. This is what we are discussing. How do you access? So first way, the easiest way that the course is going to, mostly use. So use the, and again, depending on whether it is a proprietary model or an open source model. Okay. So first thing is for proprietary models. Okay. Like OpenAI's GPT model or Gemini's, Google's Gemini models or Claude, Opus, Haiku, Sonnet, any of these models. Okay, these are all proprietary models. There are many more, or even XAI's Grok model. Okay, XAI's GROK model, and so on. Okay, so these are all proprietary models. So you can go to their website or you can make a API key. Okay, so use um, you can say API calls to these models using their corresponding SDK. SDK software development kit. Okay, so you will install the Python SDK. So for example, if you want to use the OpenAI model, you use the OpenAI SDK. Google Gemini model, there is a Google Generative AI SDK, Claude model. So all of them have their corresponding SDK, which I'll show you next after this discussion. Okay, you can directly make a OpenAI calls, and these calls are going to their OpenAI servers. I mean, these corresponding company servers. Okay, so these are all third-party companies whose models you are accessing. Okay, so no infra requirement from your side, and hence this is the easiest. But just remember that all your API calls are being monitored by these guys. Okay, all your API calls are monitored by these guys, and they may use all your data for their subsequent training. Okay, they may use your data for subsequent training. So the other option is open source models. Open source models. Now here there are again two ways we can use the open source models. One is, where are these models available? From Hugging Face. From Hugging Face. So if you go to the Hugging Face website, okay, if you go to the Hugging Face website, there are more than 2.5 million models already available. Can you see this number? I'm clicking on the models, and 2.7 million models are already there. And these are all open source model, freely available to you. Freely available to you. And these models have been categorized across these 48 tasks. On the left side, there is a tasks tab. So all these models have been categorized for these different tasks. So if you want to do a zero shot classification, question answering, text classification, token classification, or image generation, text to image to text, image segmentation, classification, these are all different tasks. So different models have been categorized with different tasks or different languages. If you want to generate text in Korean or text in English, the models will be different, right? And different models are also served under different licenses. Okay, so you can filter these models based on the tasks. You can filter these models based on the libraries you want to use them, or based on the languages, or more. I mean, these are all things which are available to you. So all these models are available for free. Okay, some of these models could be gated models, which means you'll have to accept their individual license agreements as well, but that is still free. That fundamental thing doesn't change. Okay, that these models are still available to you for free. Okay, so there are two ways you can access these models. You can download these model. Option A here is download these models. Download these models to your local GPUs. Okay, without GPU, these models will fail to run. And then use these unlimited, and then 100% secure, because now these models are disconnected. They are on your local machine. Only cons here is you need a decent GPU. If you don't have a GPU, this is not an option. Okay. If you don't have a GPU, you don't have an option. So roughly for 1 billion parameter model, you will need 2 to 3 GB of GPU. Remember, that's the simple calculation. So if you want to use a 7 billion parameter model, ideally you need 15 to 20 GB of GPU RAM. Remember that. GPU RAM. Okay. So that's the simple calculation. Okay. So which means if you have 1 or 2 GB of GPU RAM, then you can easily go for a small language model, which is like 270 billion parameter, sorry, billion parameter, or half a billion parameter model. This can easily run on a 1 to 2 GB of GPU. But if you want to run a really large language model, then the GPU requirement is insane. Okay, so this is the only constraint. Okay, you need to have a inference server setup like Olama. Use Olama, and you can actually do that. So I have Olama installed in my machine. Maybe I can show you towards the end of the session. Just remind me once. I can show you Olama, which is installed in my machine. I can show you how to run these models on local. That is option A. Option B, again, there are two from here. Let's call it as B and C as well. But B is highly unreliable, highly unreliable. Okay, let me red flag it already. So use Hugging Face inference servers. Inference servers. Okay, now which model will be available for which inference server? That keeps changing and that is not under your control, unfortunately. So I'm just going to Hugging Face platform here. Let me take one model here. Let me randomly click on one of the models. And on the right side, there are inference provider. Can you see? There is no inference provider for this particular model, unfortunately. There is no inference provider for this model, which is why this part is still blank. So let me take some other model, maybe uh, go here, transcribe, let's see. Is there any inference provider? No, there is still no. This model isn't deployed for any inference provider. So that is the problem. 99% of the models are not available for inference for free. I mean, inference providers. So let me see. You can also see for each model how many times it has been downloaded in last 1 month. So this model also doesn't have inference provider. Okay. Okay. Let me take a model for which there would be an inference provider. For example, by BG ranker. This is very common. So yes. Now this is a very, very common model by BG ranker. One of the best models for free open source embedding model. One of the best embedding models, free open source. Okay. So here, if you see, uh, this model itself has been downloaded 5.6 million times. I'm just clearing my screen, but I don't know, will I be able to get it back? So that is the thing. You can see this has been downloaded 5.6 million times. So how are people downloading it? Using a GPU. So GPU can be your Google Colab also offers a GPU. You can use that mechanism. Okay. And then there are some inference providers are there. In this case, Hugging Face itself is providing that. So if you click on this, in view usage, it will give you a small code in which you can use to so this model is being provided by getting started with inference providers. So some settings or something you might have to do. No, this is not. It says there are two inference providers. No, this is my ID. Sorry. So this is also not available for inference. So most of the models are not even available for inference, unfortunately. Let me take one of this. This is also not provided. So it's very difficult to find out a model which is bird base uncased. Let's see this one. So if you see for any of the Hugging Face models, on the right side, you can see some inference providers. If you see some inference providers means what it means is this model is already hosted on a third party platform for free and you can use some of the code provided there to access these models. So that is
Okay.
the meaning of inference provider. That means there are some third-party servers which has hosted that Hugging Face model on their own server and they are available for you to use. 0.9% models are not available on the inference mode. They are not available on the inference mode. All the models are available for download, but they are
Okay.
not available. That's why I said this is highly unreliable. So even if it is available today, that guy might want to, shut down because let's say if I'm a company, I'm hosting that model for my internal use. But during that time, I might just provide it for public use as well. Might provide it for a public use as well. That is what exactly it means. In this case, let's say few of the folks are using my model, but one of them tries to misuse it. Okay. Now, misuse can mean exceeding the rate limits or trying to keep the model literally busy all the time 24/7 with some random requests using an infinite for loop. Right. So that's like false API calls are continuously being bombarded to my inference server, and
Okay.
I'm not able to use that model for my own purpose. Then I will shut it down for public use. That model might still be running in my own company server for my internal use, but I'll shut down the public use. So even if that model is available for inferencing today, there's no guarantee that the same model will be available tomorrow for the same uh, from the same inference provider. So this is highly unreliable, and it's extremely difficult to even find a model which is available for inferencing in the first place, right? Third option for the open source model is third option is your Grok platform. That is your Grok, GROQ. That's the managed, what we call it as a managed open source hosted platform. Okay. So XAI is GROK. This is GROQ, the one which I had
Okay.
opened some time back. Okay. That playground I had been showing, right? This Grok platform. This is the one, GROQ. So this is what I'm discussing now in the rightmost side. Okay. Now, why is this managed service? Because Grok now says, okay, since Hugging Face is highly unreliable, useless. So what I'll do is I'll take the select best models, not all. So this guy has what 2.7 million models. And if it is not reliable, this is still useless, isn't it? This inference server is just a myth then. It is just nonsense. So Grok says, okay, I'll take the top 10 or 15 open source model which are best in class for their specific use. Most of them are already multimodal, and I will host them internally. Okay, the Grok will host it for us for public use for free. So you'll get some free usage limits. So Grok offers two modes. One is your free mode, and which is what we are using currently. And free mode has very decent API rate limits for those selected models, 15, 20 models. And those models also keep rotating every month or two. Okay. As the newer version of the models come in, the previous versions are discarded and the newer ones are hosted. So that is one problem with the Grok as well. So today, let's say you made an application or a POC, and 6 months down the line, you want to uh, deploy that POC or convert that into a full scale application. But the POC was done using a model, a Grok model, okay, which may not be available 6 months down the line. So you'll have to change a lot of codes. That is the problem with Grok as well, whether it is free or no. So they come up with a developer plan also. In the developer plan, the rate limits are very high. Okay, that's like they are hosting the open source model. They are serving it, but they are also charging for it. The biggest advantage is this is much cheaper. I'm using 3 times much, which means at least they are 3 to 5 times cheaper than a similar model of ChatGPT or a Gemini or a Claude or any XAI. Okay, they are much cheaper models. Okay, and inference time is very fast. You can see the inference times here. So how does it happen for enterprise? Enterprise access to these LLMs. So the previous discussion was for learning and POC mode, but now comes the discussion for enterprise. Okay. So now if you want to use the proprietary models, okay. So these proprietary models can be used in two ways. Okay. This is what we call as self-hosting. Okay. So, okay, let me use the other way around. Instead of doing this, uh, let me divide it into ways. That is basically self-hosting mode. Okay. So here you can choose an open source model and spin your own. Spin your own. Your own means Enterprise will do that. Inference server. Inference server on a GPU. Of course, you will be using one of these two. Typically, you'll use TGI or VLLM. These are the inference servers. So there will be people who will be managing all that infra, and then you can access this model. This is 100% secure. Okay, 100% secure. And of course, we will not discuss about the cost because the cost, the biggest, there are two costs here. One is the server cost that you will have to purchase one time, and there can be other software costs like VLLMs, TGI, or some other third party, softwares which you are using to manage and monitor things. Okay. So, but yes, here you are using the open source models. Okay. Because OpenAI, Gemini will not allow the enterprise to host their models in a completely self-hosting hosted mode. This is also called as on-prem models. This is also called as on-prem model access. Okay. So this is completely like on-prem server. Now, other ways you can have cloud-based gated models. Okay, now that depends. Here, there are again two choices. Okay, you can based on whether your company is using AWS or Azure or GCP or OCI. Okay, all of them will have something, some platform. Okay, where you can create a virtual private server, VPS, VPC, whatever you want to call. So you will create a virtual private server, and then these all parts are the same. It's the same. So instead of hosting it on a on-prem your own GPU, that's the only difference is instead of your own GPU server, okay, this server is hosted on AWS. Rest all headache is still the same. Rest all headache is the same. What is the headache I'm talking about? Okay, I think to some extent AWS provides some of the services like Bedrock services there if you want to use them. Okay, but if you're provisioning a direct GPU. If you want, you can also do that. You can directly take a GPU in AWS Bedrock and spin your own inference server GPU that is hosted and managed by AWS. You don't have to purchase, you just pay a monthly rent. Okay. So that virtual private server pay monthly rent, and this server can only be accessed by your organization. Okay, so pay monthly rent for GPU and infra, other infra, and use that model. Use model. Again, all the model usage is via API call, but this API call will have a custom endpoint. It will have a custom endpoint. It will not be the usual public endpoint. That will have a custom endpoint. So, a very popular service is Azure OpenAI service. Azure OpenAI service. This is very, very popular. So what we can say is so whatever, let's say open source model you are using in this case. Now there are some scenarios where, so for example, Bedrock, if you are using AWS Bedrock, you might even be able to use Claude models. Okay, so if you are going with OCI, you might be able to use maybe OpenAI models also. GCP will only allow Gemini models. Azure will only allow OpenAI models. AWS allows Claude models only, proprietary models. Open source model, literally any open source model from Hugging Face can be downloaded. Okay, and you just pay the monthly rent. So all the other concepts and discussions are same, but few proprietary models are also available in this VPC mode. Okay, now all your API calls are hitting that VPC, and that model is now isolated from. So if I just want to draw a diagram like how your browser, so this is a client, let's say on the top left. So client is your web browser that is hitting your AWS ecosystem. From there it is going to your VPC, and within that VPC there is your model. Okay, so all your API call will be restricted to this VPC, which means it will not be even accessed by AWS, because there might be other models out of the VPC. Let's say this is one model, another model outside the VPC. You can have several models which are being publicly accessed. So, for example, Bedrock. Assume that this is your AWS Bedrock service. So in AWS Bedrock service, there are 180 plus models available at any point of time. And anyone, literally anyone can use that. Okay, so these are all the other models which are publicly being used by all these people. But now, since you have created a VPC, all your API calls will directly go inside the VPC proper with authentication, and the protection is by the VPC, which means that no other company will be able to see your API calls, neither the model vendor, the model provider, or the model creator can ever see your API call. The only guy
Oh,
who might be able to intercept your API calls is AWS, but they will not do, because your company will have a SLA with AWS, maybe for 4 nines or 5 nines. 5 9 SLA, which means that this VPC will be on for uh, literally 99.999% of the times in the entire year. So the total downtime will be roughly 5 minutes per year. That is the SLA usually people have. If it is a mission critical kind of a thing, usually four nines would mean 52 minutes per year is the maximum accumulated downtime. Accumulated, not once. Accumulated downtime for an entire year is 52 minutes. That is a 99.99% availability. So your company will do that SLA. Okay. AI restriction is a completely different concept. I can use, literally, listen to me carefully. I can use a normal OpenAI model and I can still do a PIA reduction. So PIA reduction is a application layer concept. Okay, let me talk about this simply. So this is my application. Okay, and I want to use the OpenAI model. No problem. But before my API call goes to the OpenAI model, no fuss, no enterprise, no, public, sorry, no, what you say, custom deployment, no GPU, nothing. It's a simple OpenAI model that we have been talking about until now, right? What I will do is I'll create a guardrail here. Simple, a guardrail. I'll set up a guardrail. Now there are different companies. For example, if you check for Presidio is one company, or I can set up my own guardrail. I can have a guardrail which does a PII reduction. So now the actual API call which goes to the OpenAI is a redacted API call. So this redaction service will maintain what items were redacted, what PII items were redacted, and it will maintain an internal JSON file. So whenever the model will reply, it will use those redacted names. And finally, when I get my response, those redacted items will be filled back in so that my response will be as if like it was directly coming from OpenAI, but that will be going through this guardrail layer. So this guardrailing is supposed to be done every time, whether whatever way you want to use the models. Let's say even if you are using an on-prem model, you still might want to do a guardrail because compliance will not allow you to even access the on-prem model without guardrail. Yes, I'm not joking. So if you say that we have a on-prem server and you are still making direct calls to these models, your application will be trashed left and right by the regulators. So guardrail is a service which is non-negotiable, independent of how you are accessing the models. So guardrails go to this AWS Bedrock has guardrails, for example. Now that's a managed guardrail. You want to create your own guardrail, or normally if it is coming from AWS or Azure, they have a very good guardrail service. Now I highly recommend to use you know, the managed guardrail services because now what are other things? Let's say your input. Now a lot of answers you don't want the models to answer. So there is input guardrail. For example, you don't want your model to answer competitor analysis, or you don't want your model to answer or application to answer questions from the users about investment advice. Okay. Which stock is better? Should I go with Amazon or should I go with Nvidia? Which will give me better returns in future? You never know what your users will ask with your company chatbot, right? So you want your models to refuse answering such questions. That is input guardrail. This is not even PIA reduction. So there are many things. I mean, guardrailing and those security we have a separate module dedicated to that. We are discussing too many things out of the context here. But yes, guardrail doesn't just mean, you can say PIA reduction, that is more than that. So input guardrailing can be done. Prompt injection can be done by some of the folks. So you can set up a guardrail which tackles the prompt injection part also. And then models output can also be checked for safety, trust, and fairness. Most importantly, is the model's output talking, model's output could be demeaning or it might be biased against particular regions, religions. Okay, you never know. Okay, so there has to be some output guardrail also. So if the model is giving answers to some questions which is against the company policy, let's say the user was somehow able to trick the model to answer such a question. The output guardrail will, catch hold of such a question, such an answer, sorry, and block that answer. And simply the answer which will be given back to the user is, apologies, this question or this answer is against the company policy. So, for example, if you ask your DeepSeek model, okay, what are the names of North Indian uh, states? What are the names of the seven North Indian states in India? That model will refuse to answer because those Chinese models still consider North Indian states as a part of the Chinese territory. Okay, so those models fail to answer. What are the conflicts between India and China? Border conflicts, especially. The model will again fail to answer. They will not fail, sorry, refuse to answer. This is beyond my safety alignment technique, this, that, whatever language they might use. So if you are, bending the model to answer how to build a bomb or against some religious uh, gods or anything of that sort, now these models will fail to answer. Now that is the model level thing. But what if the model has generated such a answer? Then your output guardrail will capture that, and your output guardrail will filter it and give it back to the user that, apologies, we cannot answer this question, something like that. So those are your guardrails, okay? So that is again completely different concept than your PIA reduction, okay? So when we are talking about these cloud-based gated models, as I said, there are two modes. One is your VPC mode, as I said, and the other is your public mode, which I was talking about. Uh, you know, public uh, mode in public cloud mode, let's say. Okay, so for example, AWS has Bedrock again as a service. So models within the Bedrock, there are several models are there within the Bedrock, and you can use all of these models. So one is embedding model, one is a image generation model, one is a response generation model, one is a multimodal model. You can use any of these models, and there are millions of other people who are also using the same model. Okay, so that can also be done. So each model which is hosted on any of these inference server will provide a API endpoint. That's what I have been repeating all this time. So whether that model is on a Bedrock or Azure or that OCI, the moment this model is hosted on some server will provide you a API endpoint. Use that endpoint. So you go to your IT team, okay, or security team, IT security team, or cyber security team, whosoever is doing the model audit for your company, go to that IT team and ask, I want to use AI models for whatever application we want to create in our team. Can you provide us the right API endpoints for accessing so and so models? That's it. That is their job. It is not your headache to figure that out. That is what they are actually paid for 24/7 around the year. Coming back to our discussion on the architecture of these models. So, some time back, I was talking about your transformer architecture in which you have the encoder part, decoder part, encoder decoder part. So, this encoder is basically used to understand the meaning and context of the text. So, these are the typical models. Model names, you can say, which are purely encoder part. These are the models which will be used to generate text. So please understand the main reason you want to use a decoder model. So this will generate, this will understand. Okay. So when you want to do some classification, let's say you want to classify a document as a medical document or a legal document, or you want to use some sentiment analysis, or you want to mark a transaction fraudulent or not fraudulent, or you want to classify whether an email is spam or not spam. That means understanding is important there. Okay, so you will choose a model which is like Bert, Robert, Distilbert, Albert, SBERT, and so on. Okay. Whereas if you are looking for a model to generate new content, like generate an email, generate a poem, generate a jingle for your company's new product, generate a marketing email, poster, flyer, any of those, then you have to use some of these models which are generative models, truly generative models. These are not generative models, these are understanding models. Okay. Now, some of the scenarios where you need both the capabilities, you need the understanding capability plus generating capability. And these are these model. T5 is text to text transfer transformer. That's again a Google model. Okay. BART is a Facebook model. Okay. So what kind of task? Like translation. You need the model to understand the correct context and the meaning in the source language. Then it will use the decoder to generate the or text in the target language. That is the actual translation. So that the meaning and the context remains the same. Okay. Same goes with summarization. So let's say you have a 100-page compliance document which you want to summarize in 10 bullet points. So first you need the encoder part to understand that 100-page document completely. And then you need the decoder part to generate 10 bullet point summary out of it. Okay. So the correct architecture is encoder decoder in such a case. Okay. And then you have the mixture of experts also. For example, the DeepSeek model. Okay, let me give a simple example of the DeepSeek model, which is let's say DeepSeek V3 or R1. That is the model variant. This has 670 billion parameters, out of which at any point of time only 37 billion parameters are active, which is for any specialized task. Okay, what it means is, although the model has total 670 billion parameters, but not all parameters are active or not all the neurons are active to generate the final output. Only at any point of time, 37 billion parameters are active. Okay, so there is a supervisor model or a router model which will route your task to one of the smaller models. It's a mixture of 16 expert models, which is why we call it as mixture of expert model. Okay. So for example, if you want to do summarization, that then there is a specialized model which only does summarization tasks. So your task will be directly routed to a 37 billion parameter summarization model. Or if you want to do a translation, okay, it will directly route it to a translation model. Or if you are asking it to write down an email or a story, then there is a specialized model for that purpose. So it's a mixture of 16 such expert models, and that entire mixture is 670 billion parameters, but one of the expert is 37 billion parameter models average size. Okay, that's what the DeepSeek architecture is.
So it is developed by DeepSeek, right?
Yeah, DeepSeek is again Chinese company. Okay, so let's see, what is the fundamental limitation of RNN? Anyone has paid attention? Let's see, I'm sure most of you would get it right. B, so it cannot parallelize. So that is the main limitation because of which the transformer models were created. Right. This part I'll skip. We did not get into the technical details. So what is an example of which transformer architecture? Encoder, right? B is for bidirectional. Encoder is E is for embedding or encoder, you can say. Representations from transformers. That is the full form. Right. Compliance team needs an LLM to generate a suspicious activity report. Which architecture would you want to use? Okay, decoder model, basically. Okay, that's a simple generation task in that case. Why does multi-head attention? Again, I'll just skip this. This is a bit more on the architecture part. But yeah, tokenization concepts I have already discussed. These are the three main types of tokenization: byte pair encoding, word piece, and sentence piece. Byte pair encoding is used by your GPT and Llama models. Word piece is used by your BERT, Distilbert models, which are encoder. And sentence piece is used by these decoder models. Gemma is the open source model from Google. Okay, Gemma is the open source model. The proprietary models are called as Gemini. Google's Gemini model is proprietary, and Google's open source model is called as Gemma. Okay, so Gemma models also you can find on Hugging Face. Gemma models you can see. This is all from Google. Gemma 3 is the version number. 4B is the 4 billion parameter. IT is instruction tuned. That is how you read this model. Okay, so 27 billion parameter instruction tune model, right? So all these Gemma models are also available for download for free from Google. Okay. Uh, okay. So overall training process of these models. So pre-training phase is where you are teaching this model how to understand the context. Okay, basically, and generate token by token. Then these models are still called as foundation models after the phase one, and they are further fine-tuned for specific tasks. So which tasks? On your Hugging Face, this is the typical list of tasks. Go to the models, and these are the complete list of tasks. So you'll pick up one of these tasks and fine tune a model. So for example, let me just click on text classification here. So the same model, for example, BERT model. The BERT model was an encoder model which was been fine tuned on a financial data, and so it became FinBERT. Okay, this is a BG re-ranker model. So BG is basically again a encoder only model like BERT, encoder only model, which is fine tuned for generating the embeddings. Okay, so all of this you can see this is a multilingual model which will classify emotions, or this is XLMR, large toxicity classifier. Now this model was fine tuned for identifying and classifying the toxicity in the input responses. Okay, so deBERTA model is there. Twitter Roberta. Roberta is like robustly optimized BERT model, which has been fine-tuned for sentiment analysis. You can see this is a fine-tuned model on which data set? I think SST2. No, Tweet NLP. This is the data set on which this model has been fine-tuned. Okay, and these are the labels. These are the labels. So positive, neutral, and negative. These are the labels 0, 1, 2. Okay. So this model has been fine-tuned for a classification task. Fine-tuned for a classification task. So that is the meaning of fine-tuning. And then after the model has been fine-tuned before public release, they are further done alignment tuning. So what is the alignment tuning? I'll discuss that. So pre-training means just training the model for understanding the context and meaning and next token generation. This is what we have discussed just now. Training objective could be next token prediction. Okay. Fine tuning, there are three techniques. A supervised fine tuning is what I was discussing just now. For example, this sentiment analysis is a case of a supervised fine tuning. And then reinforcement learning is done for from human feedback, RLHF, what we call. So model will generate multiple responses for each prompt, and the human will rank that this response is more favorable or more desirable, okay, for a given input. And then based on that, that desired response will be rewarded, others will be penalized. This is called as reward penalty kind of a model, and a PPU algorithm will optimize the model to maximize that reward. So that is how I am teaching the model to generate responses as per my preferences or company's alignment policies and so on. Okay. And there is something called as DPO also, which is much simpler, direct preference optimization, which doesn't use a reward penalty model, but directly optimizes the model using a preference pair. Okay, so model A, model B, sorry, response A, response B. So I'll teach the model that these are the multiple responses, and you have to, select the model as per this response. So you are giving multiple such response pairs for the model to be retuned. Okay. And then scaling laws will skip. These are the model families that you should be knowing. GPT-4, 5, Claude, Gemini 2, 4, 2.x, 3.x. These are all from Google. Closed means proprietary models. Okay. And open weight means open source model. All these are self-hostable. You can download this from Hugging Face, and you can also customize this later on if you want. Okay, Mistral is a French AI company, Mistral AI. From there, you can use the Mistral models. Again, these are all hosted on Hugging Face. Okay. Yeah, Servam is missing in the list. I will be adding that. I have already discussed about Servam in the previous batches. But yeah, so cloud APIs, these are your GPT cloud. These are fastest to deploy, no infrastructure, but leaves your environment. That's the problem. Okay. So you have literally no control. These models can access your data, access your prompts, access the outputs of those prompts, and will retrain their model. Okay, later. So you need a careful PII handling and vendor risk assessment who is going to provide those access to these models. Self-hosted data stays on your premises or in the VPC. Okay, how you want to use. These are the mechanisms I had been discussing. But all this requires a proper MLOps team or a LLM ops team who will maintain and monitor that inference server, that TGI or VLLM server, and also do a proper observability dashboard and everything, and who will also do the guardrailing part, PIA reduction part. So PIA reduction is the application layer that has to be done by the developer, but guardrailing can be done by the ops team. Okay. So how these models generate text? Yeah, so whenever you give a prompt that is tokenized and the IDs are generated. So if you saw those IDs from the OpenAI platform, okay, using some sort of a tokenizer that will go into the model, that is the meaning of forward pass, and that will generate the probabilities for all the tokens. And greedy decoding means the model will take the probabilities of all these tokens um, and find out for which token, given the input context is a prompt, has the highest probability. So those tokens will be captured and given it back to you. So that is how the model will generate. Repeat means that output token is appended back. So let me give a simple example of this process. Let's say the cat sat on the, and you want the model to predict the next token. So these are the 5 tokens which have gone as the input. So now the model will generate the probability of, let's say, sky, given this as the context. The cat sat on the. That is the input context. And let's say you get some probability 0.0001. The probability of the word floor given the same input is 0.0123. The probability of the word let's say mat is something, let's say 0.4235. Probability of the word tree is, you will get something 0.1234 and so on. So model finds that because of the training data, the word mat has got the highest probability. So it will pick that word and say that, okay, the next token will be mat. Now, why is it autoregressive? Because in the what will be the next? So the input context will be the cat sat on the mat. This goes as the input context, and then the next token will be predicted. Okay, so the output which gets generated gets appended to the context for the next token to be predicted. And that is why it is autoregressive. So then it predicts, okay, there has to be a full stop or a white space or whatever that is. Okay, so each new token is generated one at a time, always conditioned on all the previous inputs tokens. This continues until a loop is generated or the maximum length is reached. So generating a 500 word summary requires roughly 700 forward passes, for example. Okay, why 700? Because 500 word means 700 tokens mostly. That's a simple rough estimation. Temperature, now temperature controls, so low temperature, high temperature, temperature controls the creativity. Remember that. So if you want low creativity tasks, let's say summarization task, straightforward question answering tasks, anything which is factual and consistent, deterministic, use a lower temperature setting. Wherever you want more creative tasks like story writing, maybe writing poems, jingles, marketing emailers, there you can increase the temperature. Okay. So it is talking about peaked probability distribution like this. And in this case, you have a more flatter probability distribution. So model gets to select a broader range of text to generate from. And this, the range is very narrow. So, okay, we'll not get into the mathematical part, but just ignore this. But this is very clear. One of the story is, if your task is any of the factual or consistent generation capability of the model, like I said already, you want a model to do sentiment analysis or classification tasks, transaction categorization task, okay, or customer inquiry has to be categorized as billing or a technical or a general query. Okay, you want a model to consistently categorize that correctly. Then you have to go with a lower temperature because you are not looking for the model's creative capability there. Okay, so for creative capabilities, just make sure that a temperature value is set to a higher value, usually zero point 0.7.
Just correct me if I'm.
Temperature is deprecated for newer models, but still very much useful. For example, grok models All the Grok models still use that. So the newer models, which are reasoning models, now they are using the reasoning effort, okay, which is there. So in the notebook that I've shared, this reasoning effort and temperature is also there, I think somewhere below. So yeah, we are anyway going to discuss on that part. Fine. So this temperature applies to non-reasoning models, but reasoning effort applies to these kind of reasoning models. So we'll talk about that in the hands-on as well. So for now, since it is there in the slide, okay, I'll take at least the initial part of it so that everyone is comfortable with the collab environment. Okay. And I'll finish this notebook later. Okay. To use LLM model and when not? So very good question. When to use a model or not. So if you are looking for a generative AI task, that is what the generative AI is. Okay. So, or if you want a model to do some thinking, reasoning, any of this. So that is where you will be using these LLMs. Okay. Or generate something or think, reason. You can also use standard machine learning models which have been trained for classification, intent classification, named entity recognition, part of speech tagging. There are already pre-built models, NLP models. We call them as natural language processing or NLP models. Okay. So, but these models are needed for predictive analytics kind of tasks. This could be deterministic in nature or could be generative in nature. Okay. So for generative tasks, you will use the LLMs. Okay. I understand that LLMs assign probabilities to possible next tokens. Yeah, that is what we were discussing. If two tokens end up with the exactly same probability, that is hypothetical impossible. So no point in doing that. And anyway, hypothetically, that is impossible because this goes up to 16 floating point. So that is impossible. Up to 16 decimal points, that will be same. And even if it is same, then uh, there is a concept called as greedy decoding, which is what I discussed, which will pick one of them. I mean, just one of them randomly. Okay. Or if you are using something like there is something called as like a branch. There is a specific name for that. Okay, I'll tell you if I remember. Okay. Hugging Face is not same as Grok. On-prem is same as local, yes. What is meant by no inference provider? No inference provider means that model is not being served by any served as a server. Okay. That is not served by any company. There is no server which is hosting that model, or there is no server where that model is currently running. Exactly. Since that model is not being hosted by a server, you cannot access that model. As simple as that. So the only way to run that model is to download and run it by yourself. So to run the Hugging Face, we need to have the inference model. You need to download that model on a local GPU and then you can run that model. Yes. So to run the Hugging Face, we need to have inference model. Not really, depends on how you are downloading that model. So if you're downloading it on Collab or something, then I mean, if you're using the Hugging Face library to run that model, it already comes. So for example, there is a transformer library. So use that transformer library, which has capability to run any of these locally downloaded models directly. And this already transformer library has been written by Hugging Face themselves. Okay. So provides everything you need for inference or training with the state of art model. You can very well see in the first line itself. Okay, here. So you will be accessing or running the locally downloaded model using the transformer library. So this is the one you need. Team is asking, please explain the difference of downloading with Collab or using with Olama. There is no point of directly downloading. You cannot anyway directly download it. You will download it mostly using the transformer library only, which means you will download it in Collab or your Jupyter notebook, either way, and use it using transformer library. If you want to somehow you have got the model. See, model is not a single file. It comes with a bunch of JSON files and configuration files and tensors and matrices and many other things. Okay. So model is not a single file. First of all, you have to remember. So when you download this model, there are multiple 6 to 7 files which get downloaded. And there are some libraries which understand those files. So you will be able to immediately use those models using these kind of libraries. Okay. Same goes with Olama. So Olama already has those libraries built in. So you can directly access those models. Okay. So I think Olama I can run, but I don't know how much RAM I have currently. It will depend, but let's see. So why people companies share available their model on Hugging Face for fun? Okay. To make their models popular, frankly, to make themselves visible. So advertisement. And they are also collecting your data. So nothing is for free. They are also collecting your data. They want to see how you are going to use that model. Okay, they want to understand that usage statistics, and so they are learning. 2.7 million models are not vanilla models. They are already super sophisticated models. I'm not even saying sophisticated, I'm saying super sophisticated models.
Yeah, they're
You get
trained.
everything from vanilla. So if you are looking for BERT, okay, so for example, if you go with this BERT base encased, this is the vanilla model. Okay, this is the original BERT model created in 2018. Whereas these are again vanilla models, but this is a super sophisticated model which has been trained on a legal data set on an Italian language legal data set. So this is a super sophisticated model. The same word which has been fine tuned. This is what we call as fine tuned model. Okay. So wherever you see, I mean, this comes with experience. Now, identifying which is a vanilla model and which is a fine tuned model for for you to find out that you need to have my level of experience and expertise. Frankly, I'll not, you know, make any excuses on that because it takes time to read models. And if you have been working with these models for more than 5 years, 6 years, you will be able to understand what these models are already. Okay. So all of these other models, you can see this is for fine tuned. So most of these models that you find are already fine tuned. So this is fine tuned model on sentiment analysis. This is again fine tuned on Turkish data set. Again, so similarly, most of the models and they are fine tuned for specific tasks also. So task specific. So for example, if I just select zero shot image classification, these are the fine tuned models for zero shot image classification. These are not vanilla models. Okay. One of them could be, so for example, the original clip model. Okay, if I just show you this clip with base patch 32. Yeah, these two are the original clip models. These are the original clip models. And all the other clips that you see, these are all fine-tuned models. These are all fine-tuned using the same clip. These are all fine-tuned versions of that base clip. Width is your vision transformer. Okay, so clip, width, base, large. Now, base large will have the different amount of encoder and decoder architectures because clip is a model which has both the text encoder and image encoder together in some proportion. Okay. So now a lot of technical knowledge is needed, but that is how it is. So these are not simple models, as I said. These are very sophisticated models already freely available to you by these guys. Okay. Fine. Sometime back, if company wanted to build AI agents such as product review agent, when we should be hosted? Are you talking about hosting the model or the application? Ideally, all the POCs should be done using whatever is freely, easily available to you on a simulated data. Even if the customer is providing you a sample data set, use that sample data set somehow internally using a local model like Olama and all. Okay, use a model within your Olama environment to generate a simulated data set. And once you have a small simulated data set, use that small simulated data set to create a bigger simulated data set. And then you can start firing API calls using OpenAI, Gemini, Claude blatantly. Because the focus is on application development and not getting into the headache of guardrail and PIA reduction. Those are the last things. First, the functionality of the application has to be made clear, isn't it? If you are spending 90% of your time in PIA reduction and guardrailing, when will you build the actual product? Okay. So the actual model headache will come when the company is ready to pay. Then you say that, okay, when you want to take this POC to actual production level, then I will give you a model, or then I will, plug in the actual model which will cater to your actual. So give a POC which is functional, but not yet ready to be deployed. Don't give them a deployable product. Otherwise, if you have already put in everything, okay, they will never come back to you, right? So that's the thing. And the second point is, let's say if I'm a startup and building a product for my own company, I'll again do the same thing. I'll do the entire POCs, show that the investors, boss, my product is fully working and functional. But if you are so much concerned about the security and safety, we'll have to deploy this model on-prem. And for that, we need $100,000. And I'm looking for equity of 5%. And then is your Shark Tank. So you have to convince the investors that if you are really interested in looking for a custom model, we need to hire 10 engineers who will build a custom model or use a on-prem model. Either way, that needs investment, 200,000, $500,000, and for that I'm looking your equity. This is what we do. This is what we do. Okay. GPU for cloud renting is probably long-term commitment, minimum 6 months. Very good point. So GPUs are not available for a week or so. Okay, you have to remember at least 3 months to 6 months GPUs are available, especially the GPU clusters. One or two GPUs might be available on demand. Okay, one or two GPUs might be available on demand, but if you want to host a, let's say, 56 GB parameter model, if you want to host a 56 GB parameter model or a 70 GB parameter model, let's say this model, Grok model, which is this Llama 70 VB versatile model. If you want to host this model, then you need at least 2 to 3 times, as I said. So you need 200 GPU. 200 GB of GPU, which means at least three A100s. One A100 is 80 GB. You need at least three of them. Or you need H100 also. That is also 80 GB. You can use either of them, A100 or H100. You need at least three of them. So that is the point here. And this is only 70 billion parameter. If you are going for a 120 billion parameter, again, the number of GPUs will even increase. And so these GPUs are not available to you directly. You have to put your request on queue. And even if it is accepted, the bigger point is they will not be available for a week or two. They will ask for a minimum monthly or, a quarterly commitment. That is absolutely correct. Very good point raised. Okay. Anything, why people companies share make available that I have already answered. Uh, I think temperature is deprecated in newer models. Yes, I have already mentioned that. The newer models means what? The bigger question is, what do you mean by newer models? So newer models, which are reasoning models or thinking models, okay, there the output is controlled by the reasoning effort, which is a customizable parameter. The prior generation models were non-reasoning models. For them, the temperature was the customizable parameter. Okay, and many of these models are still available on Grok. Okay, some of these are still non-reasoning models, so I can still use temperature for them. Okay, so as I said, I can use these Grok models for POCs or simple. So even today, I do my POCs using GPT 4.1 mini, which is a non-reasoning model. Okay, why should I use GPT-5 model or 5.2 model for a POC? Okay, unless someone is paying for it. Okay, so that is where I would especially use the GPT-5 models. Again, for agents, I would prefer to use reasoning models. If it is a non-agentic purpose, I would go for a non-reasoning model once again. Let me repeat that last statement. If I'm using a model for agent, because agent also needs a brain, then I would almost always go for a reasoning model. Okay. But I'm using a model which is not within an agent, or this is not an agentic application kind of thing. Then I don't need a reasoning model in the first place. My prompt engineering will do the job. Okay. Very, you know, deterministically. Okay. So can you confirm again, are the proprietary model hosted by cloud vendors for their managed service? Yes, I think we have already discussed that. Okay. All the proprietary models, so for example, OpenAI models, they're all powered by Azure. Okay. All your cloud models, they are already on Bedrock, but you cannot access them unless you want to, of course. So when you are directly accessing the cloud model from their APIs, okay, so you are hitting the VPC of Anthropic. Okay, let me repeat that statement once again. When you are using the Claude API, you are hitting the VPC of Anthropic. That's a custom deployment by whom? By Anthropic. So all your data is going to Anthropic. AWS cannot control it. AWS does not control it. The other way you use the same Claude model is via Bedrock. Then your API calls are hitting AWS Bedrock, and then it is going to Claude. So who is going to control the access? AWS is going to control the access and make sure that uh, uh, Anthropic is not using your data. Okay. So these are the modes. If you just check AWS Bedrock models. And anyway, Gemini models are hosted on GCP, needless to say that. And you can see the foundation models which are already there. Yeah. There are around 21 model providers already there on AWS Bedrock. AI 21 Labs, JAMA models are there. Amazon already has around 40 different models. Okay, Amazon itself has around 40 different models for different tasks, and these are the different regions in which these models are available. You can see. And along with that, some other companies are also there, like Gwen models are also there. You can see OpenAI models are also there. But which OpenAI model? Which are open source. That is the catch. The proprietary models are not on AWS. The proprietary OpenAI models are on Azure cloud. Okay. So Google's open source model are available here. These are the three open source models. These are Gemma models, not Gemini models. Remember that. Okay. So Moonshot AI, NVIDIA models are also there. Nemotron, Mistral models are available and so on. And this is a complete list. One last thing before I wind up today. There is another platform called as OpenRouter. This is again, when I say a platform, it is an application, end-to-end platform, which you can access from front end as well as back end. Mostly people use the back end. Now, the biggest advantage of this Open Router is with a single API key, you can access almost 650 models with a single API key. And that includes almost all the almost all the proprietary and the best open source models. Okay, I'll just show you. So this is our open router. Okay, forget about this. Click on the models here. The 661 models, and this number is growing. And these are Alibaba models, and these are all open source models. Sora is not. Let me type Claude. You can see 25 Anthropic models are available right from Sonnet 4.6, Opus 4.0. These are latest models. Latest models. So what I'm trying to say is you don't have to have a separate Anthropic key, OpenAI key, Gemini key, Grok key. A single open router key will give you access to all these models. A single API key. Okay. Similarly, if you are looking for Gemini models, you can see 29 Gemini models are already there. So all these are proprietary models. None of these are open source. I told you very clearly that Gemini is a open proprietary model. Gemma is open source. So 29 Gemini models are there, right from text generation to even image generation. You can see Nano Banana models are also there. Gemma models, these are open source models. So 14 Gemma models are there. You can see what else? OpenAI. So you can see all the GPTs. So 79 OpenAI models are available on this. If you're looking for DeepSeek models, they are also available. Okay, all the 25 DeepSeek models. This is the latest model, DeepSeek version 3.2 or DeepSeek R1 0528. Okay, these are the latest R1 and V3 models. Okay, they are also open source model, but okay, open source model, but paid. So this is like a bigger Grok platform, you can say. The only thing is you will have access to proprietary models as well. So Grok is a very, very small subset of this OpenRouter. Only thing is Grok will provide open source models only, whereas, sorry, open source models only, whereas this OpenRouter that will provide both open source as well as proprietary models. And the number of models is huge, 661. Whereas in Grok, the total number was how much? Maybe 15 to 20, around 20 models, you can say. So Grok is completely free. That is the main difference. Whereas OpenRouter is not. Okay. OpenRouter is not. Most likely you will have to pay to access all these models. Okay. Some of the free models are available. So how do you, so you go to pricing. Some of the free models will be marked as free. I'll show you. If you just see somewhere, open AI. So you can see these free models. Okay. So there are some free usage for these models. Okay. Remember that. So these are some free models available, but wherever there is free is not written, wherever this free is not written, then assume that these are paid models. These are all paid models. Okay, so wherever you find the free at the end, these models are free. Just like Grok is free, here also it will be free. But again, there will be usage limitations. Okay, how much you can access, the rate limits would be there. So pricing is also there along with that. So input price is zero, output price is zero, but you'll have some rate limits. Remember that. So there will be some rate limits that you can check out. Uptime. Okay, anyway, what else? I think we are done.
Well, that was day one of our Agentic AI mastery. And the next future videos, we're going to look at the multi-provider LLM setups and then how do you configure a structured output. We'll also look at the prompt engineering. We'll also look at RAG, LangChain, vector databases, chunking, a lot of other methods we are going to use. Now we are going to learn using by showing a code. So if you are familiar with Python or programming, you will love that. If you don't, I still highly recommend you to watch that to understand how these things actually happen. And probably on this channel, maybe here or there, I'll link some of the Python classes which will help you to understand the frameworks and how these are actually things are actually built. Now with that, as I said, if you're interested, the free class, roughly around 2 hours free class on Agentic AI Mastery, link should be below the description. Otherwise, I'll see you next week on the next part of this multi-part video series on Agentic AI Mastery. Atul from Team K2 Academy, take care and bye for now.